Hi, my name is Audrey Patterson, and today I will be going over two different types of related rate problems. But first, some background. So normally, related rate problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are already known. These are typically already given in the problem. The rate of change is usually in respect to time, and for these problems it is important to know how to find the area and volumes of different shapes, SOHCAHTOA, and the Pythagorean theorem, or a squared plus b squared equals c squared. Okay, let's get started. So the first example is an oil spill, and it states oil spilled from a ruptured tank spreads in a circular pattern whose radius increases at a constant rate of 2 feet per second. How fast is the area of the spill increasing when the radius of the spill is 60 feet? Alright, so I like to set it up into 5 sections: known, want, diagram, equation, and work. It just helps keep all the information organized and in place. So we know from this they give us the dr dt, 2 feet per second. So dr over dt equals 2 feet per second. And then they also give us the radius, r equals 60, of what they want us to find. And we want to find the area, so dA dt when r equals 60. Alright, for this equation you need to know the area of a circle, which is area equals pi r squared. And then a diagram would just be a circle with and then you just show the radius. Now for work, you take the derivative of this equation, so dA dt equals 2 pi r times dr dt. And then basically you just plug everything back in from what we know and what we want. So that would be 2 pi, they give us the radius, 60 times 60. They also give us dr dt, so times 2, which would equal 240 pi feet squared, this area, per second. And then typically on these types of questions, they want us to write a sentence. So for this one, I could say the rate of area is increasing because it's a positive number at 240, I don't have pi, so pi feet squared per second. And then you need to put a condition for these types of problems. So when the radius is 60 feet. And they always put the condition in the question, so it's easy to find. All right, so that's the sentence, and the answer is 240 pi feet squared per second. Now the other type of problem today is a ladder problem. So a 25-foot ladder is leaning against a house. Suddenly the bottom starts to move away from the house at 3 feet per second. How fast is the top of the ladder moving when the ladder reaches 20 feet? And again, I like to keep it organized with my little labels. But with this one, I like to start with a diagram. Otherwise, it gets confusing when you're trying to figure out what to put it as. So here's the house and the ground, and there's the ladder. So they give us that the ladder is 25 feet, and I'm just going to put some random variables here, so y and x. All right. Oh, and then, okay, so we know that dx dt is 3 feet per second. Dx over dt equals 3 feet per second. And we want to find dy dt, because that's what's moving the ladder right there. It'll go down on the wall. Dy over dt, and they give us the condition when when y is 20 feet. All right, and right there, y is 20 feet, so we can put that already right here. So y equals 20. So we know two sides of the triangle now. All right, and then for the equation, this is a triangle, so we're going to do a squared plus b squared equals y equals c squared. So, but in this problem, we put it into terms with this. So that would be x squared plus y squared equals 25 squared. All right, and now again we take the derivative of this, which is 2x dx over dt plus 2y dy over dt. And then the derivative of a constant is always 0. So we're going to do equals to 0. And then, again with this one, it's kind of filling things in. But first, we have to get the y's on the same side and the x's on the same side, so it's not combined. So 2y dt is going to stay on this side, dy over dt. And then you can subtract the 2x part over to the other side. 2x over dt. And then you can cancel. And you divide by 2y to get dy dt alone, because that's what we want to find. And you can cancel out the 2's, that's gone. And you get dy over dt equals negative x over y dx dt. So from this point, you can just plug things in that we've already figured out. So that would equal negative 15, put parentheses, times the 3, which is the dx dt, over y, which is 20. Oh, and to get the 15, it's over here. You just do the Pythagorean theorem, and you'll get 15. So all this combined equals negative 9 fourths feet per second. And again, with this problem, you do a sentence. So the sentence would be the top of the ladder slips down the wall at a rate of 9 force feet per second, and put the condition when the ladder is 20 feet up the wall. All right, I hope this helped, and good luck.